All right, welcome everyone to 2.2. Now, this first video in 2.2 is really just kind of relating the entirety of 2.1 and their concepts with derivatives. So one of the big things that we talked about in 2.1 was whether something is increasing or decreasing, right? And so remember, increasing, we kind of thought up as going uphill from the left to the right. And decreasing, we sort of thought of as going downhill. All right, so this is over here is increasing. This over here is decreasing. And another way of looking about this is looking at the slope, right? So notice where it's increasing, the slope of the function is the slope of the tangent line, all right? And over here where it's decreasing, right, the slope of the function is the slope of the tangent line. So in both cases, right, where it's increasing, the tangent line is positive slope. Where it's decreasing, the tangent line has negative slope. So all we're doing right here is relating this to derivatives. So if it's increasing, that means the derivative must be positive. Increasing is going up, positive slope, all related terms. And likewise, if it's decreasing, that means the slope or the derivative has to be negative. And again, this is just kind of relating what derivative means to what we already know. So again, derivative is slope. So up, yeah, that's positive. Down, that's negative. So that's the first derivative rule. And then we can also do something very similarly for concavity, right? So informally, we thought of concavity as whether it kind of looks like a parabola going up or a parabola going down. So up here, this was concave up. And over here, we had something that's concave down. All right, so again, one of the ways, a more precise way of looking at concavity is look at the slopes. The slopes are increasing when it's concave up, right? It goes from negative to less negative to positive to more positive. All these slopes are getting bigger, all right? And so since these slopes are increasing, we can look about this as f prime is increasing. Well, we just talked about, right? If something's increasing, its derivative is positive. So f prime is increasing, so the derivative of f prime is positive. What's the derivative of f prime? F prime prime. So concave up is just when the second derivative is positive, and similarly, right, this is when f prime is decreasing, which is when the second derivative is negative. If you ever forget which one is which for the second derivative, you can also go back and think of parabolas, right? What is a parabola? Well, the standard parabola is x squared. What is the second derivative of a parabola? Well, the first derivative is 2x. So the second derivative is the derivative of 2x, which is 2, right? So that's positive. So parabola is concave up. Second derivative is positive. All right, whereas a downwards parabola would be like this, and their second derivative would be negative. So it's one way to remember these first and second derivative rules. So to kind of summarize, right, increasing or decreasing, that's the sign of the derivative. Concave up or down, well, that's the sign of the second derivative. Uh-oh, I forgot the word of in both of these. Nothing to see here. There we go. You can't even tell it was missing. So let's do an example and see how this pans out, and we'll do some more of this in part B as well, in second video. Here we go, example 1. Fill in the blank. I like fill in the blanks. Fill in the blank for the sign. So positive, negative, or 0 at the points. So the book gives you a table here. And I want you to look at f prime, and the second derivative at 3 different points. All right, and it will also give you a function here. Let's say this function is kind of like a cubic function. And the points are A, right here, B at this relative max, and C right here. All right, so one of the hardest things about this section is going to be relating and not confusing the function, its derivative, and the second derivative, especially in the third video for today, all right? We're going to get some practice starting right now. So let's look at this first point. Let's look at A. The function value itself. The function value is the y value. Is the y value at this point positive or negative or 0? Well, the y value is positive. We're above the x-axis. The slope at that point, right? The derivative is the slope. Well, the slope here is this. Is that a positive slope? Are we going up? Or is it a negative slope? Are we going down? The slope is positive. We're going up. And now the second derivative, we'll look at concavity here. So around this point, does it look more like a upwards parabola or a downwards parabola? Well, it's going down. So it kind of looks like a downwards parabola. So we'll say it's concave down, which means it has a negative second derivative. And we'll just do this with all of them, all these points. So B, again, the function value is positive. The y coordinate is positive. The graph is up here. All right. The slope, well, let's see. This is a relative maximum. The slope is horizontal. There is no slope. It's flat. So the slope is 0, we would say. The slope is going from positive over here to negative over here. And it's 0 at that place. That will eventually be one definition for a local maximum or relative maximum. And finally, we look at concavity. In this region, does it look like an upwards parabola or a downwards parabola? Downwards. The slope is decreasing. So even though the slope is 0, the slope is in the process of decreasing, right? Slope is positive over here, it's 0 over there, it's negative over there, so it must be decreasing. To go from positive to negative to 0, slope is decreasing. And lastly, point C. Now we have a negative y value, a negative function value. Point C is below the x-axis. We're down there. The slope is, again, positive. It is going uphill right there. And for concavity, in this region, it looks like an upwards parabola, so we'll say it's concave up. All right, and that's all I want you to do. That's the first video. Good luck.